Hey everyone, welcome back to the channel. If you're new here, my name is Hussein Younes, an AI engineer, and today we're exploring one of the most important decisions you will make as an AI developer or a business owner integrating AI into your business, which is choosing the right AI agent framework. Whether you're building AI chatbots, multi-agent systems, or even enterprise-level solutions, picking the right framework can save you time, money, and a lot of headaches. In this video, we will be ranking some of the top AI frameworks out there, like LangChain and LangGraph, Microsoft AutoGen, Crew AI, and OpenAI Swarm, and much more, and like 5 more, basically 9 of them I'll cover in this video. I'll walk you through each framework, covering the essential criteria such as multi-agent support, scalability, ease of use, and more, all based on my experience building AI agents for the past 2 years. So here's my promise. By the end of this video, you will know exactly which AI agent framework is the right fit for your needs. Whether you're aiming to build your first MVP or scale up to enterprise complexity, you will walk away with clarity and insights needed to choose confidently and start building powerful AI solutions. So let's just jump straight into it. And let's start with the definition of an agent. So what is an agent? So I'll take this definition from the Hugging Face official documentation of the AI agentic framework. So an agent is just a program driven by an LLM. The agent is empowered by tools to help it perform actions that is related to that specific domain. When an agent needs specific skills to solve a particular problem, it relies on an appropriate tool from its toolbox. So an agent is an LLM powered solution. So it's powered by an LLM, or it's a system that is powered by an LLM, and the toolbox or a set of skills that the agent will use basically during the runtime tackling this problem or this task, the domain specific task that we just discussed. So thus when during problem solving the agent needs specific skill, it can just rely on an appropriate tool from its toolbox. So basically an agent is an LLM based system powered by other tools, external tools that the vanilla LLM doesn't have built into their knowledge base. So experimentally, agent frameworks generally work very well, achieving state-of-the-art performance on several benchmarks. So here's the question, like, why to bother? Why actually like to introduce agents? Why to build systems on top of LLMs while we can just use LLMs by themselves in our pipeline? So like the first intuitive solution that you're gonna come up with is that you're just gonna use the LLM directly to tackle the problem in your domain. So basically, here we can see the human eval benchmark for coding tasks, and we see that the top performing solutions here in this dataset, which is the human eval for basically like problem solving tasks with programming coding, basically based on doc strings. So the LLMs were given, or the systems were given the documentation of the tasks at hand, and they were required to solve that problem, to write code that solves that problem. And the top performing solutions were actually an agent based systems. So they are agentic systems. So here are the frameworks that we're gonna cover in this video. We have LangChain and LangGraph, Hugging Face Transformer agents, Microsoft AutoGen, Crew AI, Llama Index, OpenAI Swarm, and as a bonus, I'm adding to them LiveKit, Flowwise, and VoiceFlow, because I've used them and basically they are helpful and they could be considered as agentic frameworks as well. So also I'm gonna create a tier list, and I'm gonna basically sort these frameworks in order of their usefulness. So to actually sort them, we actually need a criteria in order to like order them in this tier list. And here's the criteria that I'm gonna use. First, LLM support. Does this framework support various large language models like GPT, Llama, Hugging Face models, and open source models? This is a very important criteria. We want our framework to be flexible, and we want to use basically new LLMs as they come, and to endorse new technologies as they come by. We have the ease of entry. How easy, how beginner friendly is this framework? How is the documentation? How is the support of this framework? Because this is very important if you want to start using a new framework. Scalability, even though it might be like easy to use, but how is this scalable for the future? Like how it can handle complex, large scale, multi-agent workflows, how it can scale in production, and basically how it's feasible to use when we grow our user base, when the number of requests grows, and when we actually want to adapt more and more features in our framework or in our system. So time to MVP, how fast you can build and deploy with a minimum MVP. So it's similar to time to entry. The ease of entry is similar to it, but here's like how much time it will take you to actually build an MVP based on their, for example, existing examples and documentation. Cost efficiency, what's the pricing structure like? And basically, will using this framework add additional costs compared to other frameworks? Like, will this framework require additional usage of LLMs in order to achieve the same results that other frameworks provide? So basically, it's going to increase the cost. The customization and flexibility, how customizable and flexible. It's similar to the scalability factor, but here we're talking about like how the framework is designed with the flexibility in mind to build basically an multi-agent system, for example, or complex workflows. How easy to do that, and how easy to adapt new technologies and new features and new LLMs. Analytics and monitoring. Does this framework provide native support for monitoring and analytics and observability of the agent? This is very important. Adaptability. Is this framework like future-proof, as I said? And can we integrate it with new technologies easily? Which is similar to the flexibility, similar to the scalability as well. Multi-agent support. How does these frameworks handle the multi-agent support? Because a very important concept of agentic framework is this concept of multi-agent collaboration and multi-agent systems. So how are these systems basically provided here? Like how they are given and how they are supported, like what is the multi-agent support in this framework. So now let's go to the framework evaluation. So let's start now with evaluating the actual framework. So let's start with the Hugging Face Transformer agents 2.0. So here is the GitHub repository of the framework. It has 134,000 stars, and this is mainly because it's part of the Transformers library. So this basically the reason for its popularity is because of the Transformers library itself, and not for basically the Transformer agents. So Transformer agents is just like an extension of the Transformers library in Hugging Face, and basically it is a modular framework for building high-performance agent-based applications. It allows developers to pair different LLMs with agents to perform complex tasks, leveraging the extensive Hugging Face ecosystem. So it's very useful if you're already familiar with the Hugging Face ecosystem. Then you can integrate basically agents on top of your LLMs directly, which is best for developers who need flexible, high-performance AI agents that can integrate with a range of tools and diverse use cases like RAG and multi-agent setups. So here's basically here is an single agent setup with Transformers agents from Hugging Face. So here we have basically the prompt, we have the call LLMs, and we have here a set of tools, or like a tool call to basically execute the skill that the agent has access to. And here's a multi agent setup. So here we have like a prompt and memory. We call an LLM, and basically we execute the tool. The problem is, if the problem is not solved yet, actually this is not a multi-agent, but this is a rather multi-step process. So if the problem is not solved yet, then the answer will be provided back, will be fed back to the agent, and the agent will basically continue solving the problem until it's marked as solved by the LLM or by the agent. So here are the key features: multi-agent capabilities, LLM support, modularity and customization, ease of use, scalability. The scalability component is that because they actually focused on this aspect, they didn't want to add lots of layers of abstractions that are unnecessary on top of the LLMs. They just provided components, which are the building blocks like Lego bricks that you can put together to build complex systems. And these blocks basically are tools and memory, tools, prompts, memory, and so on. So here is a quote from the developers of Hugging Face Transformer agents. So our framework strives for clarity through simplicity. We reduce abstractions to the minimum. Simple error logs and accessible attributes let you easily impact what's happening and gives you more clarity. So they basically focus on simplicity without a much layer of abstractions, and basically they have visibility to with error logs and basically with basically simple implementation to achieve clarity and simplicity, which is amazing when building scalable applications. Modularity, which is also an amazing thing to have. We prefer to propose building blocks rather than full complex feature sets. So instead of building basically a multi-agent system off the shelf system that you can just put into your application, instead they focused on just give you the building blocks that you can use in order to build any setup that you want. For example, instead of them building a like off-the-shelf React agent, for example, or different types of agents, or a lot of like feature sets, instead they focus on giving you the mechanism to call tools, the mechanism to have memory to your agents, and the prompts and so on, which is very helpful for the modularity aspect of your application. So for instance, since any agent system is just a vehicle powered by an LLM engine, we decided to conceptually separate the two, which lets you create any agent type from any underlying LLM. So they do not tie their implementation to a specific type of LLM, but rather you can use any LLM on top of your agents. On top of that, we have sharing features that let you build on the shoulders of giants. So basically, they have you can share your agents with other people, which I think is amazing because Hugging Face has a large community, and basically this will be supported by the Hugging Face ecosystem. So if you're familiar with that, if you like that, this is basically a very good choice for you. So here are some scores for the LLM support. I gave it an 8. It has like broad compatibility with Hugging Face models and other APIs, ease of entry. It's not so easy to enter because you need to have familiarity with the Hugging Face ecosystem itself, and you also need to have understanding of how the agent works, and basically you need yourself to put together the building blocks. However, they also have a good documentation for that. So it's somewhere in the middle. Scalability is fairly scalable, I would say, because it's built for high performance and supports scalable multi-agent systems. As I said, like you have these building blocks, you can build almost anything that like an agentic framework or an agent building framework would provide. Time to MVP is not so easy, as I said, as discussed with the ease of entry. Cost efficiency, I think it's pretty cost efficient. You can control the cost yourself because you are controlling the bricks and the building blocks into your agentic system. And here I'm not gonna go through all of them because I already explained what the Hugging Face is, and the video basically will be long if I like just state the scores for every model, so or for every framework. So this is basically the high overview of Hugging Face Transformers agents, and I think it's a great one to start with. And definitely I'm gonna put it in builder's choice. So if you want to start building agent applications, and if you already know like how LLMs work and you want to build systems on top of them, then this is a very good choice for you to start with, because it actually doesn't like you do not need to understand a lot of higher level of abstraction. You just need to understand the basic concept of an agent, and the concept of tools, the concept of giving skills to your LLMs, and you can just basically start putting these components together and build flexible applications suiting your needs of your LLM powered application. So that's why I put it in a builder's choice. I don't think it's a powerhouse because it's also relatively new. You will not find like support for more advanced features like different types of agents, visibility, deployment options, and so on. So it could be lacking some of the features that other frameworks provide. So that's why I'm not going to put it in a powerhouse. I'm going to put it in a builder's choice. It's very great to start with. So that was it for Hugging Face Transformers. Now let's go to the second one, which is probably my favorite. LangChain with LangGraph integration. So LangChain integrated with LangGraph provides a comprehensive framework for building applications powered by large language models. It offers robust support for multi-agent systems, stateful workflows, which is very important here. So for example, if you want to use transformers, like one of transformer agents, one of the things that you need to do yourself is actually you need to build the, you need to handle the state and manage the memory, manage the state, make your agent basically stateful and handle the state throughout your application, which is basically handled here for you in LangGraph. Complex interactions, making it suitable for projects ranging from simple chatbots to enterprise-grade solutions. So let's see what does LangGraph offer. It offers multi-agent capabilities, high support for complex multi-agent interactions through LangGraph's graph-based control. So as you can tell from the name, LangGraph uses the concept of a graph in order to handle your workflow. So you can think of it as a state machine defining how the workflow basically goes in your application and what is the behavior of the agent and how different agents can interact with each other. So a node can be either an agent or an LLM call, or it can be even a Python function. So here's basically here's the flexibility factor. A node can literally be anything, so you can build virtually anything with it. LLM support, compatible with OpenAI Meta, Hugging Face models, and others, providing flexibility for developers to choose their preferred LLMs. So yeah, here they have basically SDK implementations for OpenAI, Meta, Hugging Face models, and others. You can check it in their documentation, but they offer like a wide range of support for LLMs, and I would say it's suitable for most of the applications. You wouldn't need an LLM that doesn't exist here. So it's pretty good. Modularity and customizations, extremely modular because of the notion of a graph. Everything you can add as a node into your graph, and you can basically define how the state changes when the execution goes through this graph. So this allows for deep customization of workflows and agent behaviors, ease of use, extensive documentation. That's actually what I like about LangGraph, is they have a lot of examples in their GitHub repositories. So if you go to their documentation and to their GitHub, you're gonna see for every use case, actually, most probably you're gonna find a tutorial or a notebook, Python notebook for your use case, and then you can start from there and take it and build something more complicated on top of it. Also optimized for scaling applications from single agent setups to complex multi-agent systems with detailed control over the state and interactions. So that's also great. They also offer observability options using LangSmith, and deployment options using LangGraph Cloud. So it's like also an ecosystem for building AI agent applications. And basically it's one of my favorite because it offers most of the features that you can think of. It implements like papers for the best practices in the field, and also it has like a lot of support and features for every part of your workflow. For example, if you're building RAG applications, from data handling, the state managing, and tool calling, and basically most of the things that you can think of. So yes, so here are the scores. You can check them out. Actually, I'm gonna put the link in the description of the video. And I actually give LangGraph a solid powerhouse because, as I said, any functionality for building AI agents that you can think of probably exists in LangGraph. So yes, and here also there is the LangGraph Studio also, which is kind of an IDE for building AI agents, which gives you like full visibility of what's happening inside. And that's actually a very, very important point, because LLMs themselves are kind of black boxes, and the interpretability of why the LLM gave you this result is not 100% known for you. So you don't have like full control over the LLM response in some sense. You just give it a prompt and then you get an output. So it's just like input, black box, output, and then you do not have like full control over the output. Therefore, when you want to build your applications, you want to have full control of everything that you build on top of the LLM. That's why you want to have this granular visibility of every step that's happening in LangGraph. Also, if you're building conversational applications, which is I think the number one application for LLM-based AI agents, it also supports like thread management, basically. So if you have like a user base, you can split their conversations as sessions or threads, and that's basically very useful to have. So I put it as a powerhouse. Okay, so now the third framework that we're gonna talk about is AutoGen. So AutoGen is designed mainly for building and managing multi-agent conversational systems. It emphasizes modularity, flexibility, and integration with Microsoft ecosystem, making it suitable for enterprise applications. So basically, the main premise of AutoGen is that it's designed for enterprise applications. It started actually with simple implementations for multi-agent systems, where you can basically implement different types of agents that collaborate in order to get one task done. For example, here you can see that this is basically a multi-agent system for data, for building like data analysis application, or drawing plots based on data that is given to the agent. So here, for example, one agent, or a user-based agent, user proxy agent here is called, says plot a chart for Meta and Tesla stock price change YTD. Execute the following code. So this is basically this agent will take this prompt, it will basically create the code, and it will execute the code, and then he says like it got back an error, and it throws the error back to the user proxy agent. The user proxy agent says error package is not installed, and then it tries to basically it tells the other agent to install the package and then get the correct result. So this is basically one common scenario of how multi-agents basically can collaborate in this setting in order to get some tasks done. So what is AutoGen best for? It's best for enterprise developers building complex conversational agents with multi-agent capabilities and human-in-the-loop interaction. So they have it basically, one of their main native for AutoGen is like human-in-the-loop interactions, where you can basically show the result to the user, and then the user will give their feedback. And here are the key features of AutoGen and what differentiates it from Transformers agents, for example, and LangGraph. So they have asynchronous messaging, which means basically that agents, or like nodes holding agents, or basically this means that agents will communicate via asynchronous messaging, which means that when agent is executing a task, this task will not be blocking the other workflow of your system. So it's like independently will handle this task and communicates it back when the results are ready. So this is an important feature. Full type support. So basically this is also like supports typing when you want to have your LLMs produce some data types, and you want to have control over the types that are produced by the agents, which is offered also by Pydantic integration with LangChain. So yeah, they also have it. Scalable distribution, so design complex distributed agent networks. So they also have distributed agent networks for basically cross-agent communication that can cooperate across organizational boundaries. So they have basically this separation between different agents inside like one specific applications, and also agents across organization. So they basically focused on enterprise level applications. Modular extensibility is basically customize your system with pluggable components. So they handle this customization using pluggable components such as custom agent, tools, memory, and models, which basically it's the same thing is offered with Transformers agents and LangGraph. However, I think in Transformers agents and LangGraph you get more customizability and flexibility, because these they are like built-in components, and to build your own components you need to comply basically to the interfaces that Microsoft gives you through AutoGen. Whereas, for example, in Transformers agents or in LangGraph, you can literally make the agent be anything, and the tool also can be anything from a Python function to a Pydantic class. So now let's talk about cross-language support. So basically, this framework supports multiple programming languages. If you basically like programming not in Python, observability and debugging. Built-in features, so this is also good. They have built-in features and tools for tracking, tracing, debugging, and agent interactions and workflows, including support for industry standard observability with OpenTelemetry. So this is actually a good thing that they have built-in features and support for observability and debugging. For example, in LangGraph you have LangGraph Studio as an IDE, and also like traces with LangSmith to have full visibility of what's going on in details at every step of the workflow execution. So here they have something similar. So overall, Microsoft AutoGen is focused on enterprise level applications. So they will actually have most of the features that you need if you want to integrate AI agents into your workflow. However, they also suffer from a little bit less customizability because you need like to be familiar with Microsoft setup and Azure setup and ecosystem. Similar to, for example, with Microsoft agents, you need to, with Transformers agents, you need to have some familiarity with Hugging Face. However, I think here you need to be a little bit more tied to Azure ecosystem and Microsoft ecosystem. So that's a little bit the downside of it. And however, I'll put it in Powerhouse because, and also if we take a look at their GitHub repository, they have support. It's like they have 30,000 stars, which I think great. And basically the community existed for long enough now. So I think everything you want to build, you will have a good community around it and a good support in order to get what you want. So that's why I put Autogen as Powerhouse, because basically it's built for modularity and enterprise level applications. So compared to, for example, Transformers agents, it's built just to add support for agents on top of the existing LLMs inside the Hugging Face ecosystem. So that's why Autogen is more basically focused and designed for this agentic framework. So now let's go to the next one. So the next one is Crew AI. So basically Crew AI is a collaborative framework that supports role-based multi-agent systems. So the main idea of Crew AI and why it was built is to have this concept of multi-agent framework. So they have native support for multi-agents, and by default, this is how this is like their main system diagram. So here you have a process, and the process has multiple tasks. And at the same time, we have multiple AI agents, and AI agents can bind to tools in order to solve certain tasks. So here's like the concept of having like different agents for different tasks, and basically different agents have access to different tools in order to solve these tasks. So it's best for developers building collaborative role-based AI systems where dynamic task delegations and inter-agent communications are essential. However, here actually, at this point, I would like to pause and explain a very important concept here, which is the multi-agent system. So like you probably heard this term a lot. Multi-agent systems will take over the world. Agents and multi-agent collaboration is the best types of systems. But actually, like let's just like take a deeper look and see and analyze whether we actually need multi-agent system to begin with. Why can't we just put all the system in just one agent? And I'm gonna explain that actually, and I want to tell you like when is it good to use just a single agent and when to move to another agent. So like you have this node represents basically an agent. So let's say that you have an LLM based system that has access to some tools and you're solving some tasks. So here it has access to tool 1, tool 2. So in this case, what will happen if the agent, for example, wants to use tool 1? What happens usually is that the LLM will decide, it will predict which tool to use and what are the parameters for this tool to be called. So this is single agent implementation. So when you want to add multi-agent implementation, what will happen? You will have two agents, and every agent will have access to one of these two tools that we discussed in the single agent implementation. And agent 1 will have access to tool 1, agent 2 will have access to tool 2, and whenever they have the results ready, they will write to this state variable, for example. And after that, we can combine the results, the two results, or like we can take one of them, for example, depends on the logic, on the business logic of the application, and then we get the result. However, by doing so, we add extra layers of complexity and over-engineering that we might not need. For example, you need to have to manage communication between these two agents. How these two agents gonna communicate? Are they gonna write to the state in order, or they can write at the same time, or sequentially? Also, you need to have some type of task distribution system. And you also need to have some type of routing. When I'm gonna invoke this agent and when I'm gonna invoke this agent. So you add these layers of complexity in order to manage the collaboration between these agents. And basically these layers of complexity or these components that are needed to manage this communication are handled by Crow AI, for example, in this case. However, in this case, when you have only two tools, when every agent has an access to one tool, it's not good to have two agents because of the reason that I just explained. You're adding more layers of complexity to the system that are not required, because the complexity actually, or the difficulty of the task of choosing a tool is will be handled here in the distributed management system. So that, in this case, the task distribution system is reduced to just a single agent choosing between two tools. So the difficulty is equivalent, however, you're adding much more complexity to handle the same thing. So here, for example, the LLM will predict which tools to use, and here this task distribution system will also predict which agent to use. So the difficulty of this task of choosing what tool to use and what agent to use, in this case, because we only have two tools, is insignificant, and therefore it's not worth adding this layer of complexity. And also, in most cases, even like having 5 tools and around 5 to 10 tools, which is what's basically recommended by the LangGraph team, can be handled, for example, by one agent, and it differs based on your application. So if you do not have this large amount of tools where the agent actually can have mistakes and misinterpret or mispredict the tools, then using multi-agent system might not be the best thing. And here's just a representation of a hierarchical system where basically you can have multiple agents, and every agent also can be routing to two different agents in order to solve the task. So here it was worth mentioning the difference between having single agent implementation and multi-agent implementation. So here basically Crow AI manages this task distribution between the agents, and where dynamic task delegation and inter-agent communications are essential. So basically, if your application actually, in the cases that it's necessary to use multi-agents, then Crow AI is a good fit for that. It has key features for role-based agent design, autonomous inter-agent delegation, flexible task management, process-driven, which is currently supports sequential task execution, and hierarchical but more complex. So we have the sequential one and hierarchical one that I just explained here, and more complex processes like consensual and autonomous are being worked on. So it's still under development. I'm not sure how this feature could be very useful. Parse output as pedantic or gets that. However, Crow AI, what you're gonna find is that it's more of an experimental. It doesn't have support for more complex workflows, and actually not all workflows could be reduced into just different agents communicating with each other. You might need more things on top of that. And here actually when you're using like Crow AI solely, you're binding your application, or like you're tying yourself to using the abstractions that Crow AI provides. Like for example, the super dev tool here is like it's one of the Crow AI tools. So yeah, basically what you're gonna find yourself doing is that you're gonna basically be using the abstractions that Crow AI defined, and in some cases it might not be enough to have more complex applications, and like you might hit a limit where it's actually where the system becomes more complicated, and you would have like a lot of agents in order to serve your workflow. So this is basically one downside of Crow AI, except it being experimental as well. So definitely I'm gonna be putting it in experimental. So it's good just to begin with as an MVP to have this multi-agent proof of concept running, but you want to have more advanced applications with monitoring, observability, and deployment. It's going to become like more and more difficult as your application grows. So I wouldn't recommend it to be used in more complex production applications. So now let's move to Llama Index. So Llama Index is an open source framework designed for integrating external knowledge bases with LLMs. So basically, one of the also top applications of LLM-based agents is retrieval augmented generation, RAG applications, which is basically when you want to give your language model a knowledge base, like a database, because like the LLMs are trained and they have like a knowledge cutoff, but you want them to have access to you for example, your business data. You want to give them access to some documents that you have, to some documentation and databases that are not included in the knowledge base of the LLM. So Llama Index comes here to provide this connection between the LLM and databases and different types of databases and data models. So here you can basically store databases, embeddings, vector stores, and evaluation. So it supports all of that. So it's best for developers who need to build AI systems that leverage external databases or knowledge graphs, particularly for applications involving complex data processing and intervals. So basically it builds this indexing and chunking of data. So there is like a pipeline for data processing before that you can actually store it in a way that is easily reachable by the LLM, which usually involves chunking the data, splitting the data into documents, and then calculating the embeddings of these documents, like of the text. You convert the text into embeddings, and then you store these embeddings in an index that is very efficient to retrieve from when you do like semantic search. And therefore Llama Index provides you very powerful components implementing these features. So it's good for applications involving Q&A with an LLM, structured extractions, which is basically also supports data validation for the output of the LLM, chatting applications when you want to have memory and access to long-term memory and user data, also semantic search, and also agents. So Llama Index provides the bridge between your data and your applications and your agents. So it's like by itself it doesn't support, like it's not an agentic framework, but I just put it here because it can be a very powerful component of your agentic workflow. And here are some of the key features of it. Offers that data connectors with SQL, PDFs, APIs, etc., which is very powerful, which can be like a very essential part of your tools. It also provides ways to structure your data in indices and graphs, provides advanced query retrieval and interfacing over your data, allows easy integration with your application frameworks, integrates with LangChain, Flask, Docker, ChatGPT, or anything else. So it's a very powerful framework when you want to use it with data. That's why actually I'm gonna give it a niche specialist. I'm gonna give it niche specialist because it's good for applications where you heavily depend on data. When you actually want to get your agents to interact with data sources and APIs and knowledge bases and document stores. So if you have these types of applications, therefore you should go with Llama Index. It offers everything you want to need. It also has a good and established community that you can have access to if you have any issues or any problems. So let's move to the next one. The next one is OpenAI Swarm. Probably also, if you are in the field, you probably heard of OpenAI Swarm, which is the multi-agent framework that's gonna take over the world. So basically, these are the AI agents that they're gonna collaborate with each other to end humanity. So basically, in order to perform very complex tasks. So here is an overview of it. It's an experimental framework designed for building lightweight multi-agent systems. It focuses on quickly prototyping agent configurations with minimal setup, offering a modular approach that allows developers to test a multi-agent frameworks rapidly. So in my opinion, OpenAI put this up just to see that where people can take this, where people can go with implementing multi-agent systems, and whether there are actually real use cases, and whether it's gonna be like a legit thing in businesses. So they put this up and they want to see where developers can take it. So it's similar to Crew AI. It supports like a multi-agent communication. So here, for example, you have different types of assistants, and these assistants kind of like they collaborate with each other. This one will transfer to weather assistant, and this one will get the weather. So basically some form of communication, collaboration between these systems. It's best for developers looking to prototype multi-agent configurations and explore lightweight orchestration without committing to a full-scale production-ready setup. So key features is basically it explores patterns that are lightweight, scalable, and highly customizable by design. Approaches similar to Swarm are best suited for situations dealing with large number of independent capabilities and instructions that are difficult to encode in a single prompt. So If your application can be encoded in one agent with different tools, then 100% you should just go with the single agent setup with different tools. However, if you have different prompts that cannot be and different tools that cannot be given to a just single agent, then of course you should go with multi-agent implementation, and that's why Swarm comes in to basically provide this like communication with inter-agent communication and task delegation between these agents. So yeah, the Assistant API is a great option for developers looking for a fully hosted threads and built-in memory management and retrieval. However, Swarm is an educational resource for developers curious to learn about multi-agent orchestration. Swarm runs almost entirely on the client side. Much like Chat Completion API does not store state between calls. So if you're using anything for production, for a workflow with LLM agents, then 100% you need to manage the state. The state is basically becomes very, very important thing. And OpenAI Swarm is telling you that you need to implement all these things yourself, which might be a good thing, but at the same time you could use like already existing solutions for that, and to not reinvent the wheel, for example, and just use LangGraph, for example, for the state management. Now, okay, let me give it a ranking. So, as the name suggests, as actually it's written in their documentation, or it's written in their GitHub page, and the GitHub README of the repository, it's written that it's actually experimental. It's an experimental framework. So that's why I'm gonna put it, as you have guessed it, in experimental. Let's move on to the next one. So the next one is Flowise. Flowise is an open source low code platform for building and managing AI agents framework workflows using LLMs. So here actually, that's why I wanted to add some low code frameworks for building AI agents, because probably you came across them at some point when you were trying to build some AI agents. Me myself did. I also built AI agents with low code platforms before, and here is the reality of it. It's easy to start. It sounds easy to start with at the beginning. However, when the application, and especially for people who do not know how to code, and they think that learning this drag and drop thing will be easier for them to build powerful systems. So what you're gonna find yourself doing is that you're gonna start fairly simply with it, building something like simple from the interface. You drag and drop some components. Maybe there is some documentation. You start with it. You build something that consists of multiple blocks. However, at some point, you're gonna find it increasingly difficult to customize the application and get the desired results. And the reason being is that by design, these blocks, they hide from you a lot of implementation details. They hide from you a lot of details under the hood that are happening that you cannot edit whatsoever. And you need to only depend on the blocks and interfaces and variables that they have given to you. And if it might sound modular enough and they have all types of blocks that you can have access to, however, to build something flexible and scalable and customizable with it, basically your graph is gonna look like a mess. It's gonna look like there's gonna be like a lot of things involved in it to a point that it's like visually not maintainable anymore. And even though you try to maintain it, it's gonna take you more time, because you're gonna rely on your you need to see the block, you need to go to the block manually and edit its parameters manually, where when you have code, you can have more. If you have like basically a good quality code, you could have a modular system, and you could basically have every system in its own like, for example, folder structure, and you can basically have more flexibility in building applications. Also, ignoring the fact that with code you can build literally anything, while with no code you're still gonna be hit by the limitations of the modularity of the framework itself. So by choosing to use a framework, you're basically telling yourself that you're gonna hit a dead end at some point. I found that from my personal experience. I tried to build applications with it, chatbots with it, for example, and I reached a dead end. Also, I see it from clients that they reach out to me and they have basically a low code implementation that they see that it's like not flexible enough and not manageable anymore. There are like too many blocks at this stage, and also the performance is slow, and they basically want to move on with something code-based solution. So the features: drag and drop interface, wide integration support. Yeah, also actually for integrations, low-code platforms might be good because you can like just easily add for integrations that they have. Let's say, for example, they have you want to connect it with the Gmail, for example. You can basically, if they have support for Gmail out of the box, you can do it. If they have support for external APIs, you can do it depending on their interface. But again, you're tied by like you're basically limited by the integrations and features that they provide. If there is a feature that they do not provide, there's nothing you can do, and you basically need to wait for them to add it. So you're limited by what they can offer. Custom tools and templates, while for example in code-based solutions, you're not limited by anybody. You can, if there's something missing, you can just implement it and integrate it into your current system. So custom tools and templates also offers like built-in templates. Maybe that can be good at the beginning. APIs and SDK access. So also this is actually might be good, allowing for advanced customization integration with other applications. So yeah, if you hit that wall, actually maybe you can use their API and SDK in order to implement something hybrid between like Flowise and just like Python. So this might be useful. Yeah, however, that's all. I think we covered everything with Flowise, just like a drag and drop agent building framework. And I will put it in, you guessed it, quick start, because it's very easy to start with. It's just like a drag and drop. However, you hit a wall like very quickly. Your applications are going to be limited by the features that are provided by the platform. Now let's get to the next one, which is VoiceFlow. So VoiceFlow is a powerful platform for building conversational AI and voice experiences without coding. So here's their premise: without coding. It is designed to create, manage, and deploy conversational agents and workflows using a visual interface, making it accessible for both developers and non-developers. However, I think this is not realistic, because even if you're not a developer, at some point you're gonna need to integrate APIs. You're gonna need to write some code in order to support the existing functionality of it. That's why Flowise provide this API and SDK access. Same thing for VoiceFlow. If you want to build something that actually gonna be used, then you need to have more flexibility and basically to implement something more modular that suits your application. So you're again limited by the features that VoiceFlow provides, which might not be a bad thing if they like continuously improving and continuously adding the features that everyone needs, and they're getting like the builders feedback, and they're getting the feedback from the right people. This might be a good thing. However, I'm just telling that it's not a scalable approach. I tried that myself. My clients also tried that, and basically it does not work at production scale if your application needs more advanced functionality. For basic functionality, it might work just fine. So features: visual workflow builder, integration with LLMs, voice and chat support. So maybe also the voice support might be a good part. Collaborative deployment. Also, one thing, for example, like regarding the future proofing, I would say it's a 6 or 7. Why? Because although there are regular updates to VoiceFlow, however, you cannot, for example, just come from nowhere and add an LLM to yourself to VoiceFlow. To do that, you need to do it through their API, and you need like to connect, for example, like the LLM. You need to host the LLM somewhere. The LLM should be hosted somewhere, and then you need to have it interfaced with an API, and then you connect the API through VoiceFlow. While, for example, with let's say Transformers agents, you can do that like natively, just like immediately you can have an access to any LLM that anybody in the world will publish, which you do not have with VoiceFlow interface natively. Collaborative deployment, you can collaborative development, so you can develop with your friends or your colleagues, which is actually a good feature. So overall, it's similar to Flowise. It can be like different from based on your application, if you need voice or not, and the level of modularity that it offers. Therefore, I'm gonna put it in a quick start, because it's just like easy to start building things drag and drop, even if you are not a developer. So some of them can be good for a quick start. For example, transformers agents or LangGraph could be easy to start because they have extensive documentation and examples. However, if you don't know how to code, then you do not have access. Basically, you cannot easily start working with LangGraph. Even if you do not know how to code, you can basically you can handle it and build something using Flowise and VoiceFlow, for example. So let's go to the last one here we have, which is LiveKit. So LiveKit, actually, I came across it recently when I wanted to implement a demo for the Open AI real-time API. So there is a collaboration between OpenAI and LiveKit. And basically, LiveKit is an open source real-time framework designed for building multimodal AI applications and voice agents. So they have this multimodal agent where the agent have access to different types of different modalities, basically text and audio and video as well. And basically they provide SDKs to implement agents and give them access to tools and make them like multimodal. And also they have an SDK implemented for Python for the OpenAI real-time API. So it supports developing AI-driven applications that can process text, audio, and video streams simultaneously, making it ideal for complex, interactive, and synchronous communication tasks like voice and video agents. The framework integrates with a variety of LLMs and services, offering flexible agent interactions. Here are the features: multimodal support, OpenAI real-time API integration, which is how I knew them, comprehensive plugin ecosystem, which is basically the idea here of modularity of how you can build different agents through plugins, which is similar to the pluggable components of AutoGen, where you can basically plug in components for speech to text, different language models, and different types of tools. However, I see it's a little bit more difficult to customize than LangGraph. It's much less flexible and customizable than transformers agents and LangGraph. However, it's good for voice applications because they have the implementation for these plugins for speech to text, text to speech, and also voice activity detection. So for applications related to to voice assistants or multimodal agents, this can be a very good choice. And basically, I will give it a niche specialist rating or ranking. So niche specialist because, as I said, if you want to go with voice agents, then definitely you can go with LiveKit. However, if you want to have more flexible and customizable and scalable applications, then go with LangGraph or AutoGen. Also, you can go with Transformers Agents 2.0. It offers probably everything you want to have. It's going to be like a little bit maybe more difficult for you. It's going to take you more time in order to implement all the features that you want for your application, and these features might already be included in LangGraph or AutoGen. So this is all the tier list. This is everything I wanted to share with you. If you want to know how to build an AI agent from scratch, then definitely watch this video. I think you're going to learn a lot. I tell you how to develop one agent with LangGraph and how to use the LangGraph Studio in order to debug it in real time. And basically I show you everything you need to know about LangGraph and LangGraph Studio in that video. So make sure to check it out, and see you in the next video. Bye bye.